Hello, Madhu. Hello, everyone. A very good evening to all of you guys. Welcome to this second session of three-dimensional geometry. Now, this one over here is your second session. In your first session of 3D geometry, you have learned some very good problems based upon the equations of lines. Now, this one is your second session, and what we are going to do in this session, we are going to discuss about some more important problems, especially those which are related to the equations of planes. Okay, so let's start with this session. The first question which I'm going to discuss with you is a JEE Advanced 2016 problem, and this problem is based upon the equation of a plane, and there is a point given to you. You are supposed to find the image of that point first. If you look at this problem, there's a point, there's a plane, you have to find the image of that plane. After finding the image of that plane, what you have to do, you have to find the equation of one more plane which is passing through this image, and it contains this given straight line. So whenever you get these type of questions, always try to draw the correct figure. For example, and it should not be absolutely related to the dimensions or the figure which you are drawing. That should not be accurate depending upon the dimensions or anything. You can do you can just do rough sketching over here. For example, there's a plane which is given to us. Let's say this is the plane. Hello Anubhav, hello Manish, hello Madhu. This is the plane which is given to us. Its equation is also given to you, which is x minus y plus z, that's equal to 3. Now there is a point given to you. This point is P. This point, let's say, is this given point. Let's call it A. Its coordinates are known to you, which are 3, 1, and 7. And P is the image of this point about this plane. So let's say this is our point P over here, which is the image of this point A that's given to you 3, 1, 7. Now what we have to find, we have to find the coordinates of this point P, which is the image of this plane. Okay, and then after this, after getting the coordinates of this image, what we have to do, we have to find the equation of one more plane which is passing through the point P. So there is one more plane, the second plane, which is like this, and this second plane contains the point P. So our first task is going to calculate the coordinates of this image P. Okay, now how we can find the coordinates of image of any point about a plane? Always use this method. Whenever you are supposed to calculate the coordinates of the image, you will notice that the midpoint of AP, that's our point Q. Hello Vishal, hello Harish. The midpoint of this line AP, that's going to be our point Q. And the reason why this point Q is important, because you will notice this point Q lies on the plane. If A is our given point, P is the image of this point, so Q will be the midpoint of AP. And you will notice that the point Q lies on this plane. So what I'm trying to do, over here, I will not calculate the coordinates of point P first. Instead of that, I'll try to calculate the coordinates of this point Q first, because about this point Q, there is one thing special, that it lies on the plane. So let's say the coordinates of this point Q, if I say that the coordinates of this point Q are alpha, beta, and gamma. Now, since the equation of this plane is given to us, you will notice that there is going to be a normal of this plane as well. Normal to this plane. And if I have to write the equation for its normal from the equation of this plane, I can write that the normal will be I cap minus j cap plus k cap types 1, minus 1, and 1. These are the direction ratios of the normal of this plane. Okay, now if you notice something over here, AQ and this normal vector, they are parallel to each other. So can we use the condition for two vectors to be parallel to each other? Can I write over here that alpha minus 3 divided by 1, that will be equal to beta minus 1 divided by minus 1, that will be equal to gamma minus 7 divided by 1. This is the ratio which we have taken. If two vectors are parallel to each other, their direction ratios are going to be proportional. So alpha minus 3, beta minus 1, and gamma minus 7, these are the direction ratios of AQ. And for the normal vector 1, minus 1, and 1, these are the direction ratios of the normal vector. Now let's say this ratio is equal to what? Lambda. If I put this ratio equal to lambda, what I'm going to get, that alpha will be equal to lambda plus 3, beta will be equal to minus of lambda plus 1, and gamma will be equal to what? Lambda plus 7. After getting alpha, beta, and gamma, now you will notice that alpha, beta, gamma are known to us in terms of lambda. Hello Deep, if alpha, beta, gamma are known to us in terms of lambda, finding the value of lambda, that's very simple, because once again, what's the condition? That alpha, beta, gamma, they lie on this plane q. The coordinates of the point q are alpha, beta, and gamma, and they lie on this plane. So from this I can write that the equation of the plane is known to us as x minus y plus z, that's equal to 3. So alpha minus beta plus gamma, that will be equal to 3 as well. Alpha, which is lambda plus 3, minus beta, which is minus lambda plus 1, plus gamma, which is lambda plus 7, that's equal to 3. Now from this we can easily find the value of lambda. Lambda plus 3 plus lambda minus 1 plus lambda plus 7, that's equal to 3. And you will see that 3 times lambda, 3 plus 1, 7, plus 9, that's equal to 3. And from this you will get the value of lambda. Lambda will come out to be minus 2. After getting the value of lambda, we can easily find the coordinates alpha, beta, and gamma. If lambda is minus 2, alpha will be equal to what? Minus 2 plus 3. Alpha will be equal to 1. Beta will be minus lambda plus 1. So minus of minus 2 plus 1. Beta will be equal to 3. And what would be the value of gamma? The value of gamma you will get, that will be equal to, gamma is lambda plus 7. So minus 2 plus 7, gamma you will see that will be equal to what? 5. These are the coordinates of the point Q, 1, 3, and 5. I hope this step is clear to everyone. The coordinates of the point Q, which lie on this plane, alpha, beta, and gamma. After getting the value of lambda is minus 2, we got the coordinates of the point Q. Alpha, beta, and gamma, they are equal to what? 1, 3, and 5. And after getting alpha, beta, and gamma, now what we have? We have our given point A, whose coordinates were, for the point A, the coordinates were 3, 1, 7. There is this point Q, whose coordinates we have just calculated, 1, 3, and 5. And there is the point P, which is the image, and we need to find the coordinates of the point P. Now we can easily use the midpoint of formula over here. If I say this is x1, this is y1, this is z1, what will be the coordinates? What will be the values of x1, y1, z1? Using the midpoint formula, we can easily find it. I can write that x1 plus 3 by 2, that's equal to 1. So what will be the value of x1? If you solve this, x1 will be equal to minus 1. Similarly, I can write that y1 plus 1 by 2, that's equal to 3. So what will be the value of y1? Y1 you will see that will be equal to 6 minus 1, 5. And similarly, z1 plus 7 by 2, that's equal to 5. What will be the value of z1? Z1 you will see that will be equal to 3. So that's how we got the coordinates of the point P, the image, which is minus 1, 5, and 3. I hope up to this step it's clear to everyone how we got the coordinates of the point P, which is the image of the point A. The coordinates of the point P, which we have calculated, minus 1, 5, and 7. Minus 1, 5, and 3. These are the coordinates of the point P. Now after this, what we have to do? We have to find the equation of the plane passing through the point P and which contains this given line. So how we can find this? Now We are talking about the equation of a new plane on which this point P lies. We have calculated the coordinates of point P. These are -1, 5, and 3. And this plane also contains a line. There's a line given to you. Let's say this is our line, and the equation of this line is given to you. The equation of this line is x over 1 is equal to y over 2, that's equal to z over 1. So the equation of this line that's given to you guys, x over 1 that's equal to y over 2 that's equal to z over 1. Now, once we know the equation of this line, is it possible to find the equation of the plane? There is a point which is known to you, and you know the equation of the line which also passes through this plane. Madhu, you are saying that option C will be the correct one. I believe that's the correct answer as well. Your answer is correct. If you find the equation of this plane, you will see it will come out to be option C itself. Okay, how to find this equation? That's really simple. All we have to do now, to find the equation of the plane, a point passing on this lying on this plane, that's known to us -1, 5, 3. So we can use the equation of the plane, a times x minus x1 plus b times y minus y1 plus c times z minus z1, that's equal to 0. -1, 5, 3, these points lie on the plane, so a times x plus 1 plus b times y minus 5 plus c times z minus 3, that's equal to 0. Now you will notice, because this line lies on the plane, the line is lying on the plane, and the line also passes through the point 0, 0, 0. 0, 0, 0. If you notice, if I put 0 by 1, it will be equal to 0 by 2, it will be equal to 0 by 1 itself. All three of them will be equal to 0. So the line passes through the point 0, 0, 0, which means 0, 0, 0 lies on the line. And if 0, 0, 0 lies on the line, and the line is lying on the plane, so 0, 0, 0 will be lying on the plane as well. So over here, I can write that a times 0 plus 1, because the plane is also passing through 0, 0, 0. B times 0 minus 5 plus C times 0 minus 3, that's equal to 0. A minus 5B minus 3C, that's equal to 0. Let's call it equation number 1. Now, talking about the line, you will see that the direction ratios of the line are 1 to 1. The line lies on this plane, and once again, the normal vector of this plane, let's say this is our normal vector to this plane, its direction ratios we have assumed to be A, B, and C. So you will see that the direction ratios of the line and the normal vector to this plane, they are going to be what? Perpendicular to each other. So I can write one more equation, that A plus 2B plus C, that's equal to what? 0. And solving these two equations, how we can solve these two equations? We have two equations but three unknowns. How to solve such type of equation? Now both of them are equal to 0. Okay, so what we can do, a over minus b over is equal to c over. Write like this. Now when you are writing the denominator of a, what you are going to do, hide this row, hide this column, and cross multiply the other two. So you will notice what it's going to give you, -5 into 1 minus, if I cross multiply like this, -5 into 1 minus 2 into -3. When I'm writing the denominator of b, I'll hide this column. Okay, so now it will be 1 into 1 minus 1 into -3. And when I'm writing the denominator of c, I'll hide this column. So 1 into 2 minus 1 into -5. From this you will get a over -5 plus 6, that will be equal to 1, that's equal to minus b over 1 plus 3, 4, that's equal to c over 2 plus 5, 7. And we can write that, if I put this ratio equal to k, so we can write that a is equal to k B is equal to minus 4k, and C is equal to 7k, right? And the same value I can substitute over here in the equation of this plane. The equation of this plane, we were getting A times x plus 1 plus B times y minus 3, y minus 5 plus C times z minus 3, that's equal to 0. We got the values of A, B, and C in terms of k. So k times x plus b, x plus 1, this is 1 over here, plus minus 4k times y minus 5 plus 7k times z minus 3, that's equal to 0. And if you notice something, now k, 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 because the right hand side is 0, k will be cancelled out throughout the equation, and you will get x plus 1 plus minus 4 times y minus 5 plus 7 times z minus 3, that's equal to 0. If you simplify this, x plus 1 minus 4y plus 20 plus 7z minus 21, that's equal to 0. Minus 21 plus 20 plus 1, these terms will get cancelled out, and this is your required equation of the plane, x minus 4y plus 7z, that's equal to 0. X minus 4y plus 7z, that's equal to 0. So option C is the correct one, guys. The most important thing, if you notice, most of the students make this mistake. They try to calculate the coordinates of the point P first. If you do that, you will see that will take a longer time as compared to if you just calculate the coordinates of the point Q and then apply the midpoint formula. The distance AQ, that will be equal to the distance QP. Q is the midpoint. This ratio will always be equal to 1:1. The same question could be asked in another way as well, where if you look at this point Q over here, this point Q is also called the foot of perpendicular. Okay, now let's move on to the next question. I hope this problem is clear to everyone. Now let's move on to our next problem, guys. If the distance of the point P from the plane is given to you, that's equal to 5 units, we have to find the foot of the perpendicular. Once again, you can see the thing which I just mentioned. We need to calculate the coordinates of foot of perpendicular. We will be using the same concept once again. Foot of perpendicular, we need to find image of a point and foot of perpendicular. These two are one of the most favorite topics of IIT JEE from 3D geometry. So make sure you practice as many problems as possible based upon finding the image of a point and calculating the foot of perpendicular from a point to the given plane. Okay, now how we are going to approach this problem? In this question, we have to find the foot of perpendicular to this plane from this point. So once again, same concept. Let's draw a rough plane over here. Let's say this is our plane. Its equation is known to us. The equation of the plane is x plus 2y minus 2z, that's equal to alpha. You will notice that I'm highlighting this point alpha over here because now the complete equation, the exact equation of the plane, that's unknown to us. The equation of the plane that's given to us in terms of an unknown constant alpha, which we need to calculate eventually. Okay, now from this plane, there is a point. The point is P, which is 1, minus 2, 1. And from this point P, a perpendicular has been drawn to this plane. And we need to find the foot of perpendicular. This point Q over here, this is our foot of perpendicular, and we need to find its coordinates. Okay, so the first thing what we are going to do, we will try to calculate the coordinates of the point alpha. To find the coordinates of the point alpha, one condition is given to us, that is the distance of this plane. The distance of this plane from the point P, that's equal to 5 units. This distance PQ is equal to 5 units. So the same I'm going to use to find the value of alpha. The distance of any plane, if there's a plane given to you, AX plus BY plus CZ, plus d, that's equal to 0. And if you're supposed to find its distance from any point, let's say x1, y1, z1, so the perpendicular distance is always equal to modulus ax1 plus by1 plus cz1 plus d divided by square root of a square plus b square plus c square. This is somehow similar to how we used to calculate the perpendicular distance of a point from a given straight line. The same we are doing over here. It's just that this time, instead of having a straight line, we are having a plane. Okay, so the distance will be equal to mod of a times x1. In the equation of the plane, all you have to do, plug in the coordinates. So 1 plus 2 into minus 2 minus 2 into 1, and if you take this alpha on the left hand side, minus alpha divided by square of the coefficients of these terms, which is a square plus b square c square. So 1 square plus 2 square plus minus 2 whole square, and this distance is known to us, which is equal to 5 units. So I can write 5, that's equal to mod of 1 minus 4 minus 3 minus alpha divided by square root of 1 square plus 2 square plus 2 square. This value will be equal to what? 9. Square root of 9, 3. If you take this on the left hand side, you will get 15. That's equal to mod of minus of 6 minus alpha. And since there is a modulus over here, if there is a modulus over here, so this quantity is supposed to be positive. And one more thing which is known to us, that alpha is greater than 0. Alpha is a positive value. So minus 6 minus alpha could be equal to plus 15. Minus 6 minus alpha could be equal to what? Minus 15. If minus 6 minus alpha, that's equal to plus 15. For this, what should be the value of alpha? For both of them, if we have to calculate the value of alpha, could you tell me what will be the value of alpha for both of them? The value of alpha. And there's a small mistake over here. This value minus 2 into 1. If I calculate this, it will be equal to what? Minus 2 into 1. This will be minus 2. So this is going to be minus 5 minus alpha. So minus 5 minus alpha, that's equal to plus 15 minus 5 minus alpha, that's equal to what? That's equal to minus 15. For this, the value of alpha which you will get, that should be equal to 10. For this, the value of alpha which you will get, that should be equal to what? Minus 20. And what's given to us, that alpha is positive, alpha is greater than 0. So the value which alpha can take, that will be equal to what? 10. The value of alpha will be equal to 10. So now we got our correct equation of the plane. The equation of the plane is x plus 2y minus 2z minus 10, that's equal to 0. This is our required equation of the plane. Now, once again, we need to calculate the foot of perpendicular. Same concept I'm going to use over here. x1, y1, z1. Let's say these are the coordinates of foot of perpendicular. So normal vector of this plane and foot of perpendicular. Normal vector of this plane and foot of perpendicular joined to this point P. If this is our normal vector, once again, PQ is parallel to the normal vector. So I can write PQ, if I have to write, the direction ratios would be x1 minus 1 divided by normal vector 1. That's equal to y1 plus 2, the normal vector 2, that's equal to z1 minus 1, normal vector minus 2. And let's say once again this ratio is equal to some constant lambda. From this you will get the value of x1, y1, z1 in terms of lambda. X1 will be equal to lambda plus 1, y1 will be equal to 2 lambda minus 2, and z1 will be equal to minus 2 lambda plus 1. These are the values of x1, y1, z1 in terms of lambda. And once again we are going to use this condition that x1, y1, z1, x1, y1, z1, which is our foot of perpendicular, that lies on this plane. So x plus 2y minus 2z minus 10 equals to 0 if this is our plane, which means x1 plus 2 times y1 minus 2 times z1 minus 10, that will also be equal to 0. Now just substitute this value in terms of lambda. So what you are going to get, you will get that lambda plus 1 plus twice of 2 lambda minus 2 times minus 2 lambda plus 1 minus 10, that's equal to 0. Lambda plus 1 plus 4 lambda minus 4 minus plus 4 lambda minus 2 minus 10, that's equal to 0. And if you calculate the value of lambda, you will see you will get 9 times lambda minus 10 minus 2 minus 4 minus 16 plus 5 minus 15, that's equal to 0. Lambda will be equal to 5/3. This is your value of lambda. After getting the value of lambda, you can substitute lambda over here. You will get the coordinates x1, which is equal to lambda plus 1. So 5/3 plus 1, which is equal to 8/3. Hello, Sangam. And you can see once you got the x coordinate, it's 8/3, the x coordinate of foot of perpendicular. If you look at the options, only one of them is having their x coordinate as 8/3. So obviously option A, that's going to be the correct one. Okay, so you can see, guys, these two questions, very recent problems. This is advanced 2016 question. This is IIT JEE 2010 question. Both of them based upon the same concept, finding the image, the question, and with the image, along with the image, one more concept has been mixed. Okay, obviously you are not going to you are not going to find the straight question where you're just supposed to find the image or the foot of perpendicular. One more concept will be mixed if it's an IIT JEE advanced question. Okay, now look at the next question. That's another very simple one. This time what we have to do, we have to find the equation of the plane passing through the line of intersection of these two planes and at a distance of 3, 1, minus 1 from this, at a distance of 2 by root 3 units from this point 3, 1, minus 1. Now once again, this time we have two planes. Plane 1, and let's say this is our plane 2. Now if you notice, these two planes are intersecting with each other. So when two lines are intersecting with each other, if two lines intersect with each other, what we get a point where the two lines are intersecting with each other. But when two planes intersect with each other, what we get line of intersection. If I say this is AB, so AB over here, that's called line of intersection, where the two planes are intersecting with each other. AB is our line of intersection. Okay, now what we have to do, we have to find the equation of the plane passing through the line of intersection. So you will notice, how if I ask you one question, how many planes are possible passing through the line AB? Will there be a single plane passing through the line AB? You will notice, if I draw one plane like this is a plane passing through the line AB. If I draw one more plane like this is another plane passing through the line AB. If I draw one more plane like this is another plane passing through the line AB. If I draw one more plane over here, this is another plane passing through the line AB. So you will notice there are infinite planes which can pass through the line AB. But to how we are going to identify which is our required plane, you will notice our required plane. About our required plane, it's been specifically said that its distance from a point, I'm saying that this point is P, so its distance from the point P is given to you. Its perpendicular distance from the point P, that's given to you. Okay, so what we have to do, we have to find the equation of this plane. Now this plane will be fixed, which is at a distance of 2 by root 3 units from the point P. So the first thing, whenever two planes are given to you, let's say if the first plane is r vector dot n1 vector, that's equal to d1, and the second plane is r vector dot n2 vector, that's equal to d2. If you have to find the equation of the plane passing through the line of intersection of these two, its equation will be r vector dot n1 vector plus lambda times n2 vector, that's equal to d1 plus lambda times d2. This will be the equation of your required plane. Similarly, if the same two conditions are, if the same two equations are given to you in the Cartesian form, let's say the first plane is a1x plus b1y plus c1z, that's equal to d1, and the second plane is a2x plus b2y plus c2z, that's equal to d2. So the required equation of the plane will be a1x plus b1y plus c1z minus d1 plus lambda times a2x plus b2y plus c2z minus d2, that's equal to 0. This will be the required equation of the plane. Okay, so all we have to do is plug in these two planes over here in this equation. If you substitute the equations of these two planes, the first plane, that is x plus 2y plus 3z minus 2, the second plane plus lambda times our second plane, the second plane, that is x minus y plus z minus 3, it will be equal to 0. Now if you simplify this equation, what you will see, that x times 1 plus lambda plus y times 2 minus lambda plus z times 3 plus lambda minus 2 minus 3 lambda, that's equal to 0. This will be your equation of the required plane. And in fact, this single equation, you will notice, for different values of lambda, this equation will represent all the planes passing through the line AB. This equation represents all the plane which pass through this line AB, the line of intersection of the two planes. It's just that the value of lambda for these different planes, that will keep changing. These planes, the value of lambda according to the equation of the plane will keep getting changing. Now in this case, how we can find the value of lambda? To find the value of lambda, we can use this fact that, hello Anil, hello Sangam, that the distance of our required plane from this point P, which is a very good evening to you too, 3 1 minus 1 is 2 by root 3. So once again, if we use the distance concept, the distance this time is equal to 2 by root 3 of this plane from the point. The point is known to us. Point is 3 1 minus 1. So from the point 3 1 minus 1, the distance of our plane, that's equal to 2 by root 3. So 2 by root 3 is equal to mod of 3 times 1 plus lambda. All you have to do, plug in the values of x, y, and z, plus y times 1 times 2 minus lambda plus z times minus 1 times 3 plus lambda minus 2 minus, well, I'm good, Anil, how are you? Divided by, now divide by the squares of the coefficients of x, y, and z. So 1 plus lambda whole square plus 2 minus lambda whole square plus 3 plus lambda whole square. Now if you simplify this equation, guys, you can square on both sides. I can write that 2 by root 3, that's equal to, if you simplify this, 3 plus 3 lambda plus 2 minus 2 lambda, 2 minus lambda plus minus 3 minus lambda minus 2 minus 3 lambda divided by, in the denominator you can expand these squares as well. It will be equal to square root of 1 plus lambda square plus 2 lambda plus 4 plus lambda square minus 4 lambda plus 3 plus 9 plus lambda square plus 6 lambda. If you simplify this equation, 2 by root 3, in the numerator you will see, you will get 3 plus 2, 3 minus 3, let's cancel this out. 2 minus 2, this will be cancelled out as well. 3 lambda minus 3 lambda, this is also cancelled out. You will notice that only minus lambda is left. So minus 2 lambda divided by, if you add all these terms, 1 plus 4, 5 plus 9, 14 plus 3 lambda square plus 2 lambda minus 4 lambda, 6 lambda, 4 lambda. This is your equation. If you square on both sides, you can easily find the value of lambda. I'm just skipping through this part. You can easily solve it. If you solve this one, you will see that the value of lambda will come out to be minus 7 by 2. This will be the value of lambda. And after getting the value of lambda, All you have to do after getting the value of lambda is minus 7 by 2. You just need to plug in that value. So you will see x times 1 plus 1 minus 7 by 2 plus y times 2 plus 7 by 2 plus z times 3 minus 7 by 2 minus 2 minus plus 21 by 2 equals to 0. This will be your required equation. And if you simplify this equation, you can see that the coefficient of x, if I just find the coefficient, minus 5. The coefficient of y, that's coming out to be 11. 2 into 2, 4, 7 plus 4, 11. So there is only one equation which is satisfying this. Coefficient of x 5, coefficient of y minus 11. So option A, that will be the correct answers. Okay, so you can see, guys, in this class, the thing which we have learned, the most important topics, if I talk about the equation of the plane, related to that, image of a point. In the JEE exam, these are the some of the favorite topics: image of a point, finding the foot of perpendicular, distance of a point from a line, distance of a point from a plane, equation of a plane passing through a given point. Equation of a plane passing through a given point, also containing one line. So these are some of the favorite topics, some important topics for your JEE advanced preparation. I hope this session was helpful for you. The problems which we have solved, advanced as well as the JEE mains exam, the problems which we have solved in this class will be useful for you. Try to solve these questions once again by yourself. If you need any more help of Meritnation for your IIT JEE preparation, just register on this link. Okay, regarding any of your doubts, or you need access to any of the content, you can just register on this link and we'll get back to you. Okay, all the best, guys. Thank you so much. Bye, everyone.